This question was not on the TMUA 2024 paper, or at least legally, that's what I have to say. It is given that 0 is less than or equal to f of x is less than or equal to 1 for each x between 0 and 4. Furthermore, it is given that the integral from 0 to 2 of f of x dx is 1, and the integral from 1 to 3 of f of x dx is 3 over 2. What are the range of possible values of the integral from 0 to 4 of f of x dx? And of course, if this was a TMUA problem, which of course it isn't, there would be a bunch of options here. So in fact, this is slightly reworded just to make it a bit more friendly for the video. Let's have a look. How do we approach this? Well, we want to find the integral from 0 to 4, or the range of possible values it can take given the information that we have. Now we know the integral from 0 to 2, so that kind of does half of our work. We now need to think about the integral from 2 to 4, which annoyingly we don't have. It'd be a bit too easy otherwise. So let's start with the minimum possible value of this integral. We're trying to minimize this curve and thankfully minimize the area under this curve, and thankfully the curve lies entirely above the x-axis, so we don't need to worry about any negative areas, silly things like that. So if we're trying to minimize, now we know that the integral from 0 to 2 of f of x dx is 1, and the integral from 1 to 3 of f of x dx is 3 over 2. There's a small overlap in that region, namely the region from 1 to 2. So let's mark this on. So 0 is there, 1 is there, 2 is there, 3 is there, put 4 over there. That's our x-axis. And now we know that the area from 0 to 2 is 1, so maybe that area there is 1. And we know that the area from 1 to 3 is 3 over 2, so maybe it looks something like that. Well, actually, sorry, it would obviously have to have the same red bit because it's all one function, but then maybe this bit here. So when I add that and I add this bit, I get 3 over 2. Now, we want to minimize the area from 0 to 4 of f of x dx. But of course, we still need these two, the red and the blue conditions here to hold. How can we, in order to minimize the integral, that means we want to maximize the amount of overlap here. Because then, in other words, we maximize the amount that we've double counted to get these two results here. Now, what's the maximum value we can have for our function in between 1 and 2? Well, it's precisely 1, because of this, but also because of this condition here. So as long as we make the function just a flat line 1 there, then that way there's as much overlap as possible between these two regions, 0 to 2 and 1 to 3. And so this is the line y equals 1. And then the function here will just be a flat line of 0, because we need the area from 0 to 2 of f of x dx to be 1. And then from here, we just need the area to be half. So it doesn't really matter what the function looks like. Maybe we can just choose the straight line, that goes from there to there. Okay, cool. And then there's no information about what happens between 3 and 4. And since we're trying to minimize the value of the integral from 0 to 4, let's just make the function as small as possible, so 0. I'm struggling to draw straight lines today. There we go. Okay, great. So what is the smallest value that the integral from 0 to 4 of f of x dx could be? Well, it's 3 over 2 precisely. So f of x dx, or the integral from 0 to 4 of f of x dx is at least 3 over 2. Now, what's the biggest value that it could be? Well, now we're going to do some similar logic. So now we want the least amount of overlap between the interval 1 and 2. Now, we've got to be careful here. You might just say, okay, well, let's just make it 0. So if we do the same thing, draw up this interval. If we want the area from 1 to 2 to be as little as possible, we can't make it 0. Why not? Well, because of this condition here, we need the integral from 1 to 3 of f of x dx to be 3 over 2. But because f of x is bounded above by 1, the maximum area we can have here is 1. So between 2 and 3, the maximum area we can have is 1. And so that means we still have to basically put the rest of the area, so the 0.5 that's left over, in this interval here. Doesn't matter how it goes, just draw a function like this. But now, of course, we still need the integral from 0 to 2 of f of x dx to be 1. And so, again, the function just has to be a half here. It doesn't matter how it looks. Let's just say something like that. Great, cool. And we're trying to maximize now. So we want the area from 3 to 4 to be as big as possible. So make f of x just 1 there. And so we get that area there. And so what's the maximum possible value? Well, it's 1 plus 1 plus 2 halves, so 3. So f of x, the integral from 0 to 4 of f of x dx, is any number between 3 over 2 and 3. Hopefully that makes sense. I'll leave my previous 2 videos on screen. I'll leave one of them on screen where I solve another question which looks suspiciously, or may look suspiciously similar to one that appeared in last year's paper. But if it does, that's purely by coincidence. I'll catch you over there.